All right, next example. We want to find the probability of either drawing a red card or a face card. This is an inclusive event because it's possible to be both a red card and a face card at the same time. All right, so we can either use the formula or use the Venn diagram. Let's do the Venn diagram first. So this middle region will be cards which are both red cards and face cards. So there are two red suits, hearts and diamonds. Each suit has three face cards, Jack, Queen, and King. That means there's going to be 6 of those cards. Next, red cards, which are not face cards. Now I know that half the deck is going to be red, meaning that we'll have 26 red cards. If 6 of them are face cards, then we've got 20, which are not. Next up, face cards, which are not red. Well, we've got 2 suits, which are not red, spades and clubs, 3 face cards each, giving us 6 of those. And so the probability of being either red or face would be add those 3 together, 32 out of 52, or 8/13. Using the formula, the probability of a red card is 1 out of 2, or 26 out of 52. The probability of being a face card would be, well, for every suit of 13 cards, 3 of them are going to be face cards. You could also write this as 12 face cards out of 52 total cards in the deck. The fractions value will be the same. And then subtract the cards which are both red and face cards. So there's 6 red face cards out of 52 in the deck. So then getting common denominators, we could make a common denominator of 52 if we want to. It's 26 50-seconds plus 12 50-seconds minus 6 50-seconds. 26 plus 12 is 38, minus 6 is 32, which we saw earlier simplifies down to 8/13. And so we get the same answer either way. Next, we have a situation in which we had 3,510 drivers surveyed, 1,950 were male, and 103 were colorblind. Only 6 of the colorblind drivers were female. We want to know the probability that a driver was either male or colorblind. So we know that the total number of drivers is 3,510. And so this will be our male section. This will be colorblind. And this will be the both male and colorblind section. So what we know then is that only 6 of the colorblind drivers were female, meaning that if there was 103 colorblind drivers total, that there were 97 male and colorblind drivers. So this middle section is both male and colorblind. So let's put a 97 there. This entire area is all the colorblind, which would then have to total 103. And so we would have the 6 female colorblind drivers in this part. So of course, this region is not drawn to scale. Now the problem also tells us that we have 1,950 male drivers surveyed, which means that this whole region needs to equal 1950. If this portion of it equals 97, then the rest of the region would have to be 1,853 people in this region. So then, using the formula that's already partially printed for you on your sheet, we've got the probability of male. So that would be 1950 out of 3510. The probability of colorblind would be the 103 total colorblind out of 3510 minus the probability of being both male and colorblind, which is this middle region, this intersecting region here, giving us 97 out of 3510. And so add and then subtract our numerators, and we would get 1,956 out of 3,510. We divide those both by 2, we get 978 over 1755. There might be another common factor in there, possibly of 3, so perhaps we can simplify it down a little bit. Why don't I pause and grab a calculator so we can do that? If you divide both of those, numerator and denominator, by 3, you should get 326 over 585. If you did this using the Venn diagram, you could add these 3 numbers together, and that would get you 1956 out of your total number of drivers, which was 3,510, and then you would simplify the same. All right, that's good. See you in class.